Assalamualaikum warahmatullahi wabarakatuh. Good night, everyone. Okay, so in this session, we are going to discuss frame analysis, continue the one that we have done in class today. Okay, so in class today, you are given this type of frame. Okay, where you have triangular load like this. The value is 80 kilonewton per meter. Original, this is fixed and pin A, B, C, and D. Okay, the distance is 7 meter, 5 meter, 5 meter, and the frame for member AB and CD. Member AB and CD has 2 EI, and this is EI. Okay, this is the frame. This is the frame. Okay, using flexibility method, we are going to analyze this. So in this frame, let's say R1, redundant number 1 is moment at A, and redundant number 2 is HD. Okay, so we have three possible primary structure. This is possibility number 1, where we have to remove. We have to remove MA, we remove HD. Okay, so from this actually we know that there are three structure, determinate structure. So from general equation, it is from general equation. So actual frame equal to primary frame plus redundant MA applied, and the other one is redundant HD applied. So we have redundant MA applied, redundant HD applied. Okay, so we start from the general equation. So in the general equation, we know that there are three systems to be analyzed. Okay, system number one is primary frame, where from this we will calculate, or we will write M naught. And for redundant MA applied, this is R1. So this we will write M1, and this is M2. Okay, so we start with analysis of determinate frame. It is primary frame. So primary frame. Primary frame. In primary frame, we have to analyze. Okay, we remove one from fixed, so it become pin here. We remove one from pin, it become roller. So we label AY or VA. So this is DY, and this is AX. So our task now is to calculate the reaction. This is 80. 7 meter, 5 meter, 5 meter. Okay, so in the primary frame, we have to calculate, reaction in order to to write the moment equation. Okay, take a break for a while. Okay, so the first system to analyze is primary frame, and we analyze primary frame in order to get the moment equation, and to have the moment equation we must have reaction first. So that is why we have to calculate reaction. Okay, so we calculate reaction at pin A, uh, pin support A, pin because we remove a moment at A, and roller at D because we have removed dx from D. Okay, so you have calculated in the class today, right? So the AX value is 280 kilo Newton. dy is 261.33, if I'm not mistaken. Please check. Okay, kilo Newton, and AX is AY. So AY is negative 261.33 kilonewton. Okay, this is based on what we have calculated this morning and afternoon. Okay, so what most important, as I said, is the value of reaction in the diagram. Okay, the value itself. Okay, so dy is 2, 261.33. AY is negative. AY is 261.33 and AX is 280. 261.33. No, 149 whenever you choose, it depends on your redundant. Because remember, we have three choices, three option, three primary frame. Frame, okay, we have the first possibility, R1 is MA, R2 is HD. The second possibility is R1 is MA, R2 is HA. Third possibility is R1 equal to HA, R2 is equal to H, not H, V. V, silap. So this is R1 is, we remove pin. We remove pin from D. Pin from D, so HD and VD. So we have three possibility. Okay, so each possibility will give us different primary frame. Okay, so for the solution, every you can use any possibility, okay, that you like, except the redundant is given in the question. Okay, in my case, so I choose moment at A and HD, horizontal reaction at D as the redundant. So that is why I get this. Okay. Okay, so this is whenever R1 is MA, R2 is HD, so we get this value of reaction for the primary frame. Okay, so next one, go back to the general equation. We will have redundant MA applied. Redundant MA applied. So we just every time we want to do, we just refer to the general equation. So always remember the general equation: actual structure equal to primary structure plus redundant 1 plus redundant 2. So every time we have to start with this. So this will guide us what next to do. Okay, so this is the primary frame. So now we are going to determine reaction in redundant MA applied for redundant 1. Okay. So we move to redundant MA applied. Redundant MA applied. So for redundant and MA applied, we have to remember we will have to remain the support that we assume after removing redundant. So one pin at A, one roller at D. One pin at A, one roller at D. This is A, B, C, D. This is 7 meter, 5 meter, 5 meter. Okay, redundant MA applied means we have to apply a unit value at A. A unit value of MA. A unit value of MA. So from this, we calculate reaction. We calculate reaction, again, reaction at A and reaction at D. Okay. This is AY, this is DY. Okay, it is 1 minus 5 dy. By taking moment at A is equal to 0, we get 1 minus 5 dy is equal to 0. So dy is 0.2. Okay, dy is 0.2. dy is 0.2. So dy here is 0.2. So the other one will be ay, negative 0.2. Okay, this is primary, this is redundant, not primary. This is redundant MA applied. Redundant MA applied. Okay. Okay, next is refer back to the general equation. Okay, the third one is redundant HD applied. Redundant HD applied. So we will have the same type of frame. We have same type of frame. This is redundant HD applied. Redundant HD applied. So we have the frame. Okay, with same support. Okay, now redundant HD applied. Redundant HD applied means we have to apply a unit value of HD. Okay, so we apply a unit value. Okay. Okay, now from that we will calculate A Y D Y N D, not DA. This is A. This is AX. Actually, automatically when we have put this as positive 1, so the other one should be what? Negative 1. So that the system is in equilibrium. Equilibrium. Okay. So now taking moment at, so we have A, B, C, D. Taking moment at A is equivalent to 0. So what we get is negative 5, negative 5 dy. It is negative, right? Towards A. And we have to plus with 1 times 2. 1 times 2. It is positive. 1 times 2. Okay. So dy, we get 2 divided by 5. 2 divided by 5, it is 0.4. 0.4. So means dy is 0.4 and ay is negative 0.4. 0.4. Okay. So now we will focus on the 3 determinate frame. This is the first one, primary frame, where in primary frame we will write M not. In redundant MA applied, redundant number 1, this is M1. And for redundant HD applied, this is redundant number 2. This is M2. M2. Okay. Okay. We will write the moment equation in table form. Okay. So we will summarize all the moment equation in the table. So we list all the member, origin, limit. We have M0, M1, and M2. in the table. Member, origin, limit. M0 from primary frame, M1 and M2. Okay, so we have to list all member. We have member AB, BC, CD. Okay, for frame for AB, we will choose origin at A. For CD, we choose origin D. And for member BC, we will choose, we can choose either B or C as redundant. Cannot be A, cannot be D, because X move in straight line. So whenever we write the moment equation for BC, we have to choose either B or C as origin. However, look at the easiest side. Okay, and the easiest side, so this is BC. The easiest side will be located at C. Okay, so we choose C as origin. Okay, so for the limit, AB means the length of AB. AB means length of AB, so the length is 7 meters, so it is from 0 to 7. BC, BC, the length is 5 meter. The length is 5 meter, it is from 0 to 5. And CD, the length is 5 meter, it is from 0 to 5. Okay, so now we have to fill in the moment equation into the table. Okay, fill in the moment equation into the table. Okay, we go back to this, the primary frame. Okay, so cutting section. Origin A means moment counterclockwise. Origin D means moment clockwise. Origin C means moment clockwise. Okay, so for member CD, CD means like this. This is M, not. This is D. Okay, so the moment is 0. The moment is 0. So we put 0 here. 0. Okay, so now we will do the moment equation for BC. Okay, for BC, it is 261.33 moment clockwise. So this is M naught. X means this distance. This distance. So this is X. Okay, X start from origin. X start from origin. Okay, so for this section, so we get M naught is equal to 261.33 X. So put this 261.33 X into the table. 261 261.33x. Okay, now we focus on the triangular. Okay, focus on the triangular. Okay, cutting like this. Okay, we have 280. 280. Moment is acting counterclockwise. This is M naught. And remember, this point is not 80. Okay, this point is not 80. So what we should do is we have to interpolate to find what is the value. Okay, we have to interpolate. 80 and 7. So if this is A, this is X. So the value should be 80 divided by 7, X. 80 divided by 7, X. 11.429. 11.429. So the value here is 11.429x. 11.429x. Okay. 11.429x. Then we write the moment equation. The moment equation, so this is A. So X is this distance. Okay. So taking moment at the cutting point is equal to 0. So minus M naught plus 280x plus 280x, and we have to minus the area is 1 over 2 11.429x times x. That is the area, because the area is force. The area is force, and the length, the centroid is located somewhere here. Okay. The centroid, it is 1/3. Okay, we have to times x. So whenever you have the triangular load, we will produce x cube. Okay, so this is M naught is equal to 280x. Okay, we minus by x cube. What is the value? What is the value? 1 over 2, 11.429 divided by 3. Okay, please calculate this value. This value, what is the answer? Wait. Okay, 1.905. Okay, it is 1.905. So this one is 1.905. So we put this equation in the table. It is 280x minus 1.905x cubed. Okay? Is it the right one? 1.905, 280x. Okay, 280x, 220x minus 1.906 or 905. Okay, x cubed. Okay, so settle moment equation for primary frame. Okay, now we want to write the moment equation M1. M1 we refers to redundant MA applied. Redundant MA applied. Okay, for redundant MA applied, again for member CD. Member CD is just like this. This is M1 and M1 is 0. Okay, M1 is 0. Okay, next is member BC. Member BC is like this. We have 0.2. This is M1. Remember the X is this distance. This is X. Okay, so it is 0.2x. 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 Okay, next is AB. AB is just like this. This is the cutting section. This is the moment M1 and this is 1. This is 0.2. So we get M1, negative M1 plus 1 is equal to 0. Negative M1 plus 1 is equal to 0. So M1 is equivalent to 1. Okay? So this is 1. Okay, next, we move to M2. M2, we take from redundant HD applied. Redundant HD applied. Cutting section, 3 cutting section. Moment, okay? Moment equation, the moment direction. Okay? So, for member AB. For member AB, okay, for member AB, we have this. This is M2. X is this distance. This is X. Okay, 1 times X minus M2. It is X. Okay, 1 times X is positive. We minus by M2, 0. So M2 is X. So this is X. Okay. For CD, what about CD? This is A. This is A. What about CD? CD, we have 1 here. And moment clockwise, this is M2. Okay. X, the distance is X. And this is M2 minus 1 times X. M2 is X. So we get X. And for BC, 1, 0.4. Moment clockwise, this is M2. Okay, so this one is 5 meter, 1 times 5. And 0.4, we have to time with X. This is X. Okay, so M2 minus 1 times 5 minus 0.4x. So M2 is 5 plus 0.4x. 5 plus 0.4x. Okay, so this is what I mean. You have to focus on what, okay, what is important. Okay, the important that you have uh to write, okay, write the general equation in order to guide you the system, the type of structure. Primary frame, redundant MA applied, redundant HD applied. And then we want the moment equation, because the moment equation is the input in the displacement formula. Okay, because we are going to determine the redundant, and redundant, we get redundant from compatibility equation. What is compatibility equation? It is displacement at redundant position. And under displacement formula, there are moment equation. So we write moment equation so that we can determine the displacement, and then we can solve for the redundant. Okay, after the moment equation is displacement. So we write from the compatibility equation. This is to guide us what next to do. Okay, remember redundant one is MA, so it is theta 1 naught and delta 2 naught. Okay, and we have 2 by 2 matrix, F11, F12, F21, F22 times with redundant MA, redundant HD, equivalent to 0 except when there is a support settlement occur. So this is the standard form of compatibility equation. Okay, so why we have the moment equation? Because we want to calculate displacement, and we should understand that displacement come from integration of moment equation. Okay, so now six there are six, because we have to find two displacement in primary frame, two displacement in redundant one, two displacement in redundant two. That is why we get six displacement. Okay, so now we want to calculate the theta 1 naught. Theta 1 naught. Theta 1 naught, the notation give us, we know from the notation we use 1 and naught. 1 and naught means we will times these two. 1, M1, M naught. M1, M naught. Delta 2 naught, 2 and naught. Okay, now, actually having this table, you don't have to rewrite the equation. You don't have to rewrite the equation because just looking at the table, use calculator and straight away put all this equation into calculator and calculate the answer. That's all. Okay, so take out your calculator and please calculate for me. Okay, and don't forget in this case we have to consider 2, 1 and 2 EI. EI in this case, don't forget. You don't need to write everything. Okay, so focus on your aim. Okay, our aim is to calculate redundant MA and HD. And in order to have that, we have to have the compatibility equation. And in compatibility equation, we have 6 displacement. Because of 2 redundant, 6 displacement. Okay, so displacement we get from integration of moment equation. Okay, we just need to use whatever notation that we use here. Okay, 1 naught, 2 naught, 1 1, 1 2, 1 2 equivalent to 2 1. So we have to do only once. 2 2. 1 naught means M1 M naught, 2 naught M2 M naught, 1 1 M1 square, 1 2 M1 M2, 2 2 M2 square. Okay, so refer to the table. So just focus on the table and calculate. Calculate delta 1, sorry, not delta, theta 1 naught. Theta 1 naught means that this time this divide by 2, okay, plus this and this, okay, this one is 1 EI. Okay, the total of that will give us theta 1 naught. Theta 1 naught. Okay, can you calculate for me the value? We put directly into the compatibility equation. Okay, please calculate for me 280x minus 1.905x cubed times 1. Integrate. Limit is 0 to 7. Wait, I want to open the calculator. Okay. So now we will fill in all the displacement symbol with the displacement value. Okay. The first value to be determined is theta 1 naught. Theta 1 naught. The first value to be determined is theta 1 naught. And theta 1 naught is, we integrate to 80 x. We minus by 1.905 x cube. No. X. X first. X cube. Close bracket. Times with 1. M1 M naught. M1 M naught times 1. The limit is from 0 to 7. Okay? M1 M naught. M1 is 1. M naught is 280x minus 1.905x cube. Okay, we integrate this. Okay, we get 5716.552. And don't forget, we have to divide by 2 because member AB is 2EI. So we divide by 2. Okay, we get 2858.26. 2858.26. Okay, this one we plus with new one, new equation, new section BC. So BC is 261.33x times with 0.2x. The limit is from 0 to 5, close and close. Okay. So please check, you get the same answer for theta 1 naught. It is 5036.012. Okay, please check the answer. Please check for me the answer. Okay, so for compatibility equation, okay, we get 1 over EI. The first value is 5036.018. 5036.018. That is the first value. Theta 1 naught. Sama Okay. So next one is theta 2 naught. Not theta, delta. Delta 2 naught. So for delta 2 naught, we have to refer to M2 and M naught. M2. This is M naught, M1. Okay. Okay, now we want to calculate delta 2 naught. Delta 2 naught. 2 naught means M2, M naught. Just look at the table. Okay, use calculator to integrate M2 and M naught. M2 and M naught. And again, we just need to consider AB and BC. Because CD 0. Okay? You don't have to write the formula. You don't have to write the equation again. Okay, you just from table, please directly calculate the value, the answer. Okay? So open back calculator. Okay, now we are referring to M2 and M naught. M2 and M naught. Okay, so we integrate. Okay, it is x times 280x minus 1.905x cubed. Okay, it is x. Okay, it is x. Okay, x. M2 is x. M2, M naught. M2, M naught. It is 280 x minus by 1.905 x cube. Okay, the limit is from 0 to 7. Okay, this is the answer. And don't forget, we have to divide by 2. Okay, it is 12,804.93. Okay, this one we have to plus with, okay, it is M2 5 plus 0.4x. It is 5 plus 0.4x times with 261.33x. Close bracket. The limit is 0 to 5. Okay. 33493.558. Okay, previously 018 ke 110118. Okay, other please check. Okay. Okay, for delta 2 not 33493 ya, 33493 33490. Ashraf kata 0118. What about the rest? 0118 ke 018? 0118. 0118. Okay. Okay, this one 33493. Please check. 33493 0.558, 0.558. Okay, 3 decimal places. Okay, 33,493,558. Okay, this is delta 2 naught, delta 2 naught. So continue to find the 4 value of flexibility coefficient F11, F12, F21, F22. Okay, so now we want to determine F11. F11 means that we have to refer to this. Okay, we have to refer to M1, column M1, M1 squared. So we have to integrate this. Okay, so okay, 1 square from 0 to 7 close equal divide by 2. That is for AB. Okay, plus BC, BC. So plus, we have to plus. It is 0.2x. Square from 0 to 5. From 0 to 5. Okay, close another one. So we get 5.167. 5.167. 5.167. So this one is 5.167. 5.167. Okay, next one is M1, M2. M1, M2 means we have to focus on this. Okay, and again, there is 0 here. So we just need to consider two members, AB and BC. AB and BC. So use calculator. Okay, we calculate the value. 1 and 2 means 1 times with x times with times with x, limit from 0 to 7. Okay, divide by 2 because of 2 EI, and we have to plus another one for BC. For BC, it is M1, M2 is 0.2 x times with 5 plus 0.4 x. Close. The limit is from 0 to 5. Two bracket. Okay. So the answer is 28.083. Okay. 28.083. Please check, yeah. Please check. 28083. 28083. 28.083 for 1, 2 and for 2, 1. 28.083. Okay, the same value. Symmetry. The matrix must be symmetry. And F22. 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 So for F22, we just need to focus on this only. M2 squared. M2 squared. Okay. So we integrate M2 squared. It is X from 0 to 7. From 0 to 7. Okay. We have to divide by 2. 2 EI. Okay. And then we plus by, okay, it is 5 plus 0.4 alpha x. Okay, 5 plus 0.4 x. Okay, put the limit from 0 to 5. Okay, close. Allah. How to get back? Okay, please calculate for me. I do not know how to get back to the previous one. I have to redo again. X square from 0 to 7. Total. The total is 87. 87.167, yeah? Total, total A, B, A until D, eh? Total including member CD. Okay. I just use total including member CD. 87.167. 87.167. Okay. So this one we times with M, A and H, D. And this is equal to 0. Okay, this is the compatibility equation. Okay, we get directly from the table. Okay. So next we want to solve this. Solve. Okay, solve this means we have to key in the value of A, B and C. Okay, so this compatibility equation is actually equivalent to two simultaneous equation. Means that you have to bring this value to the other side. Okay, because this is A1 value. This is A1. This is B1. A2, B2, C. C1 here. C2. After we bring this value to the other side. Okay. Format calculator. Okay, now we want to solve this using calculator. Okay, you have to plus all this, yeah. You have to plus this and this and this. Okay, tadi kan keluar syntax error tu. Okay, you have to plus all. Plus all. Okay, Ashraf kata kalau include member CD, value dia 99.667. Isn't it? 99.667. Okay, the other please check. You have to plus all. Previously, we just consider AB and BC because CD is 0. Okay, for M2, we have all. We have all. We have AB, we have BC, we have CD. So we have to plus all. Okay, so now we want to solve this using two simultaneous equation using calculator. Equation 2 unknown. Okay, A1 is 5.167. B1 is 28.083. And C1 is negative 0, 0 pula. Negative 5036.012. Okay, A2 28083. B2 is 99.667 and C2 is negative 33493.558. Okay, it is negative because 0 minus. Okay, we bring to the other side, so it is 0 minus. So that's why we get negative. Okay, so MA value is negative 1602.903. 1602. M is equal to negative 1602.903. Okay, this is kilonewton meter. And HD is equal to 115593. 115593. 115593. This is kilonewton. 115593. Okay. Okay, this is the redundant. Negative 1602.903 and HD is 115.593. What does it mean? Okay, this means this is the actual frame. Actual frame. In actual frame, this is pin and roller. Okay, the loading 80 and moment at A is negative. Negative means this is 1602.903 and HD is positive. Here is 115.593. Okay. Okay, now we can continue to calculate back to calculate remaining reaction. And calculate remaining reaction, we have actually two option. Okay, either Either we want to calculate using equilibrium equation, or we want to calculate using principle of superposition. Okay, I want to show to you how are we going to calculate the remaining reaction using principle of superposition. Always refer back to the general equation. So we want AY, AX, and DY. We want to calculate these three unknown reaction, the remaining. And I want to show how we can calculate using principle of superposition. Okay? And remember, when using the principle of superposition, we have to refer back to the general equation. We have to refer back to the general equation. This is the general equation. Okay, now we are going to determine three remaining unknown reaction, which is located in actual frame. And to have the value in actual frame, we can get from the general equation. It is primary frame plus redundant MA applied plus redundant DX applied. Means that in this diagram and in this diagram, we have to times with MA value and we have to times with HD value, the redundant. Okay, so so we are going to determine AY. Okay, AY in primary frame is negative 261.33. This one. Not M. VA. AY in primary frame is 261.33 negative. Follow the equation, we have to plus with redundant MA applied, and it is negative 0.2. This negative 0.2, we have to times with MA, the value of MA, the redundant, plus AY in redundant HD applied, this value, we have to times with HD value. Okay, so we get like this. To get AY, what we get is negative 261.33. That is AY in primary frame plus with AY in redundant one is negative 0.2. Negative 0.2. So we have to put negative 0.2 MA plus for redundant number 2 is negative 0.4. Negative 0.4. So it is negative 0.4 HD. Okay. Everything inside the redundant diagram, we have to times with the redundant. Okay, the redundant that we remove. Now we already have the redundant, so we have to times back. Okay, so it is negative 261.33 minus 0.2 times negative 1602.903. Negative 1602.903 minus 0.4 times HD. And HD is 115.593. Okay, this is another option. To get the remaining reaction using principle of superposition, we refer back to the general equation. So we get AY. Okay, the answer. And of course, we do the same for AX as well as DY. And we will get the okay, the remaining reaction. The remaining reaction. Okay, so you have two options. Either you want to use the equilibrium equation. Okay, either you want to use the equilibrium equation, or you can directly use the principle of superposition from general equation. Okay, because all value have been calculated in the beginning of the process, so you just need to apply back, and then you will get all the remaining unknown reaction. Okay, so that's all about how to determine reaction, 5 unknown reaction in indeterminate frame. Indeterminate frame. Okay, so remember, in flexibility method, we use flexibility method whenever we cannot calculate 5 unknown reaction directly, because only 3 can be solved using equilibrium equation. So we have 2 redundant. 2 redundant. And these 2 redundant can be determined using compatibility equation. Compatibility equation. What is compatibility equation? Compatibility equation is come from displacement. Displacement. Okay, and inside displacement, we have moment equation. Inside displacement, we have moment equation. And moment equation we get from reaction. Okay, we get from reaction. When we want to write moment equation, we must have reaction. Then only we can write moment equation for beam and for frame. Okay, so how many system we have? We have all together. Okay, for 2 redundant, we have M0, M1, and M2. Okay, okay. So for the compatibility equation, when okay, like this, F11, F12, F21, F22 times with R1 and R2 equivalent to 0. Okay, this is whenever there is no support settlement. This is 0, 0 because no support settlement. Okay, now let's say settlement is given. Settlement can be settlement can be in X direction, in Y direction, as well as in rotational direction. Okay, rotation means for the moment, for the redundant moment. Okay, so what if in the question support settlement, you have to consider whenever the settlement is given in the question. If it is not given, then you will get this compatibility equation equivalent to 0. When there is support settlement mentioned in the question, then you have to consider that, and you have to put in actual system. Okay, in actual system. Okay, consider support settlement. Support displacement at D. okay, at D, the value is 2 mm horizontally in right direction. Okay, this is example of support settlement, support displacement, slip, rotational displacement. Okay, mentioned in the question. Okay, it is actually support settlement. Okay, consider support displacement at D. Okay, it is 2 mm horizontally in right direction. In right direction. Okay, first thing to understand is, okay, the easiest way to solve this is by choosing redundant. Redundant. This one is delta at D, and this is horizontal displacement. Horizontal displacement. Horizontal DH. D, this at D and H horizontally. Okay, horizontally, or X, doesn't matter. Okay, it is 2 mm. 2 mm. Okay, you have to choose. Dia macam ni, kalau ada support settlement, number one, redundant tu adalah support settlement tu. Redundant and support settlement is at same position. Tadi kan redundant number 2 ni is HD. HD. So HD ni dengan yang ni same position lah, same position. When it is same position, then only you can set equal. Okay, kalau contoh redundant 1 is MA, redundant 2 is HA, but settlement is at D, 5 mm. Okay, nampak tak? Yang ni dia dekat D, but yang ni dia dekat A. Dekat A. So tak sama kan? Tak sama position. Tak sama position. When tak sama position, you cannot put equivalent to 5 mm in the equation directly, cannot. Okay, but in this case, when okay, in this example, okay, when we have theta 1 naught and delta 2 naught plus M, A and HD, okay, this will equal to 0.005. 0.005. So this one is delta. Okay, horizontal displacement. Okay, it move horizontally. Move horizontally. Location is at D. Okay, the value is 0.05. Okay, so whenever the support settlement is given in the question, we have to consider that, and we have to put the displacement, the support displacement in actual system, actual structure. And from that, we have to determine the new redundant, as well as and reaction lah, remaining reaction. Okay, whenever we have support settlement, we have to consider that we put into the compatibility equation. It is not equal to zero anymore, but it is equal to the redundant value. Okay, remember the settlement is 2 mm, 2 mm horizontally right direction, right direction, right direction. So we put 0.005 positive. Okay, positive. Okay, then we have to calculate the new redundant, and then we also will get the new value of remaining reaction in the frame. Okay, do you have any question? Okay, that is the second one. Okay, the first one, okay, we have settled. So you have understand how we analyze indeterminate frame. One redundant, two redundant. One redundant is just like beam analysis. This is two redundant frame analysis, and I have also introduced you the support settlement. So dalam modul tu ada example-example yang saya dah masukkan support settlement example. So please try to answer that. Okay, this one is about the support settlement, so try to finish this by tonight. Okay, and full solution of what you have salin from this session, I want you to upload in the OneNote. Okay, so you buat tadi kan together with me, so you have to upload in OneNote. Upload in OneNote. Okay, you just need to go to your page, your page, yeah, under homework, and just add page. Just add new page and then upload print out. Insert print out. Okay, insert print out. Okay, so I actually want to continue another session to discuss uh, on further analysis of flexibility method, but not this in this session. Further analysis, yeah, further analysis, but you have to know, because that is not new to you actually. Further session lah, further session. Okay, in that session I want to give you example how we determine displacement. For example, calculate uh, rotation at C. The diagram is this. This is the diagram. The same frame. Okay, A, B, C, and D. But the question is calculate rotation. Calculate rotation at C. Calculate rotation at C. So I want to have another session, okay, to discuss how we can determine or calculate rotation at any point in indeterminate frame. Indeterminate frame. Remember, rotation or displacement, we can calculate using unit load method. And in unit load method, we have two systems. In unit load method, we have two systems. One is real system, real structure, and another one is virtual structure. And real structure is actually actual structure. Okay, actual structure. Inilah actual structure. Okay, so I will set one session, one extra session to include discussion about how we determine displacement in indeterminate structure. Okay, unit load method you have learned in determinate structure subject. Okay, you analyze rotation or displacement in determinate structure. Now, this is indeterminate structure, so we still use unit load method to analyze displacement. Okay, so we will have another session for that. Okay, so we have remaining 20 minutes for you to take attendance in the U future. Please do so. I want you to submit tonight session. Okay, until the new value of redundant and remaining reaction, considering support settlement. Okay, considering support settlement. So in order to solve for for new redundant value, since settlement is given in, yeah, in unit meter or millimeter, you have to have E and I value. E value and I value. So please assume E and I value. Normally we use 200 and 500. Okay, so you have to include E value and I value, then only you can solve for the new redundant and the new reaction. Okay, so that's all for this night session. Okay, don't forget to submit. So submit by tonight. Okay, so just continue about 10 minutes or 20 minutes to finish this, and please upload into OneNote. Okay, thank you very much. Assalamualaikum warahmatullahi wabarakatuh.